So the repetition, here we repeat the definition of the number of degrees of freedom. The number of independent admissible variations in a complete set. Okay? This is the number of degrees of freedom. Now, geometric constraints are things that remove degrees of freedom. Okay? That's an obvious thing. And then the definition of a holonomic system and the non-holonomic system. Okay? The system of holonomic system is a normal system. It's the system for which the number of admissible variations, independent, is the same as the number of generalized coordinates and the same as the number of degrees of freedom. And the great news is that all mechanisms in this unit will fall into this category. Okay? So for holonomic systems, simply the number of generalized coordinates is equal to the number of degrees of freedom, because it's the same as the number of independent variations. However, the non-holonomic systems have the situation when the number of degrees of freedom is not equal to the number of generalized coordinates, because the number of admissible variations is smaller, as in the case of the rolling disk. Okay? And such systems are called non-holonomic, and they are much more common than students hope, because essentially anything with rolling pairs falls into this category, plus some other things. Okay? Holonomic, the origin of the word is Greek, and it means integrable. So it's integrable and non-integrable, right? Something like this. Holonomic systems are much easier to analyze, and analysis of non-holonomic systems essentially falls outside the scope of undergraduate and master's courses. So you begin touching non-holonomic systems only when you go for a PhD or something. Right? So one could say now, okay, I don't need to worry about non-holonomic systems. The only thing I need to be able to is to recognize the one when it pops up, and then not try to deal with it. Just ring a consultant. Okay? But holonomic systems we will do, and all our mechanisms will be holonomic in a sense that, in a sense of a definition, that the number of degrees of freedom will be exactly equal to the number of coordinates we use. And this number of degrees of freedom for mechanisms is called in mechanism slang mobility. Okay, so now you can see that your group project on mobility is a group project on degrees of freedom, really, yeah? But using different terminology. Different communities use different slang.